Hello, it's Sir France again, and in this video, we will be learning about operations of functions. Yes, you heard it right, operations of functions. Now let me share you my PowerPoint. Let's start, everyone. And before that, I would like to give the credits to Miss Yan Gilig for making the PowerPoints for the general mathematics of my video. Thank you so much, Miss Yan Yan, and I really appreciate the PowerPoint. Okay, let's start, everyone. Operations on functions. We have four operations to consider. Function operations are the following: addition, subtraction, multiplication, and division. For addition, we have the form of the quantity f plus g times x, which is equal to f of x plus g of x. Why? By applying the distributive property, that's how you're going to get that. Same goes with subtraction. The quantity of f minus g times x is equal to f of x minus g of x. And for multiplication, the quantity of f multiplied by g times x is equal to f of x times g of x. And for the division, we have f over g times x, which is equal to f of x all over g of x, where g of x should not be equal to 0. Okay, now let's try to have an example here. We will be answering these examples. Okay, the first function, we have f of x, which is equal to 3x minus 4, and then g of x, which is equal to x squared plus 6x plus 5. Okay, let's start with addition. Following its operation. Okay, here you go. As you can see, f plus, or the quantity of f plus g times x, which is equal to f of x plus g of x. Okay, so all you need to do is to substitute there your f of x, the function of f of x, and then the function of g of x. Okay, so our f of x here is 3x minus 4 according to the given, plus our g of x, which is x squared plus 6x plus 5. And after that, all you need to do is to combine like terms or simplify the whole equation. So as you can see, we need to do it from decreasing order. So the variable with the greatest degree will be our first term. So as you can see, combining like terms, x squared, bring down x squared, copy x squared right there, and then 3x plus 6x. So as you can see, they are like terms, and then that's equal to 9x. And constant numbers, which is negative 4 and 5, you combine them. Negative 4 plus 5, which is equal to 1. Therefore, our quantity of f plus g of x is equal to x squared plus 9x plus 1. Okay, that's how easy it is. Next, how about a different operation, which is subtraction? Let's try. Basically, the same thing. All you need to do is to substitute your f of x here minus g of x, okay? So f of x is 3x minus 4 minus, okay, you need to put it in a parenthesis, minus the quantity of x squared plus 6x plus 5. Sir Franz, why do we need to put the expression into parentheses, or why do we need to put it inside the parentheses? It's all because following the rule of subtracting a polynomial, yes, this expression is a polynomial. So we need to follow that. So the rule of subtracting a polynomial, all you need to do is the sign of each expression will be changed. Okay? So as you can see, each term has its own sign, right? It will be changed. Why? That's the rule. So copy or bring down 3x minus 4 minus, okay, since x squared is positive, it will turn into negative x squared. So where is the minus sign? That will change into positive, right? And then positive times negative, we have negative x squared because the value here or the sign here of x squared will change into negative. So basically, I simplify it already. That's negative x squared. And then the sign of positive x will change into negative x. And then the sign of positive 5 will change into negative 5. After that, you combine like terms or you combine similar terms. Okay, in decreasing order, okay, your variable, which is the highest degree, is x squared. So you bring down first negative x squared because you cannot combine x squared with the terms here since we only have one term or one expression who has a power of 2, who has the power of 2. Bring down negative x squared. And after that, you combine 3x and negative 6x. So 3x minus 6x, that is negative 3x. And after that, negative 4, which is the constant, and another constant, negative 4 minus 5. In operating, that is negative 9. Okay, so why do we get negative n? It's all because negative 4 minus 5, following the rules in subtracting integers, you're just going to simply uh, add the numbers and then follow the negative sign. Next, how about a different operation, multiplication? So we have here, same given, guys. Okay, substitute 3x minus 4 multiplied by the quantity, which is g of x squared plus 6x plus 5. And all you need to do there is to apply the distributive property. You need to start first with 3x. 3x times x squared, that is 3x cubed. 3x 3x times 6x, that is 18x squared, because 3 times 6 is 8, that's 18. X times x, that's x squared. Next, 3x times 5, that is 15x, because 3 times 5, 15, and copy the x. Minus, okay, since we have here a subtraction sign, so minus negative 4 times x squared, that is negative 4x squared, and negative 4 times 6x, that is negative 24x. And lastly, negative 4 times 5, that is 20. Don't forget the basic rules, guys. That is very important because we're always going back to the basic rules, applying it here in operation functions. Next, combine like terms, okay, and simplify. As you can see, we only have x cubed here. So in decreasing order, bring down 3x cubed and then 18x squared, combine it to your negative 4x squared. So that will turn into positive 14x squared y, 18 minus 4, that is 14. And then copy the x squared of our variable. And then we have 15x minus 24x. Okay, and operating that one, 15x minus 24x. Since negative 24 has a greater value for its digit, which is 24, all you need to do is to subtract them. 24 minus 15, that is 9. And then follow the sign of 24. It's all because 24 is bigger than 15. Next, since we only have one constant here, which is negative 20, bring down negative 20. Therefore, our f multiplied by g of x is equal to 3x cubed plus 14x squared minus 9x minus 20. Yes, that's how we do the multiplication. How about for division? Okay, the same given, and then this is how we operate that one. Substitute the numerator, which is f of x. We have 3x minus 4. And then our denominator, which is g of x, that is x squared plus 6x plus 5. And then, so how will you answer that one? As you can see, look at your denominator. Your denominator may have, this is a perfect square trinomial, right? And you can factor it out. So by factoring it out, so all you need to do, finding the factor of 5, which is 1 and 5, whose middle term is 6. So when you add 1 plus 5, that is 6. Okay, you can recheck that one by doing distributive property on your own. Okay, therefore, our answer for f over g of x is equal to the quantity of 3x minus 4 all over the quantity of x plus 1 times the quantity of x plus 5. And that is the final answer. Because you cannot simplify that anymore. But if you can simplify the answer, you need to simplify that one. Okay, so we need to have a simplified answer or depending on the instruction. Next, solve for the following. Okay, this time it's your turn to solve our given. Okay, number one. Okay, you try to answer it on your own. I guess, sorry. Okay, I'll give you 5 seconds. And then you pause the video and then try to answer it on your own. Okay, just pause the video. Okay, so once you're done answering, I'll show you here the solution or the answer. So this is how you should do it. And this is what should be seen in your solution paper, okay? Following the rule, substitute the given, which is q of x plus n of x. So we have q of x, which is x minus 1 all over 4, plus n of x, which is x over 2. Then you operate that one by applying the LCD rule. So what is the LCD of 4 and 2? We have 4. And then do the process. 4 divided by 4, 1 times x minus 1. So we write here x minus 1 plus 4 divided by 2, that's 2 times x, so 2 times x. And then you simplify or combine like terms. So as you can see, x and 2x, you can combine them, and then negative 1. Okay, so we combine x and 2x, that's 3x. Okay, below 3x minus 1 all over 4. Therefore, our q of x plus n of x is equal to 3x minus 1 all over 4. Okay, I hope you got the correct answer for that. Now you try to answer this one also. Okay, I'll give you 5 seconds and then you can pause the video and try answering it on your own. Q, the quantity of q plus n of 0. So as you can see, the value of x has a value 0. So you apply first the evaluating of function and then proceed with the operation of function. Okay, that's how important the evaluation of function is or evaluating function is. Okay, I hope you're done and this is how you should solve it. I hope we have the same solution, or if you don't have the same solution but arrive with the same answer, that's basically it. Okay. Okay, this is how I solve it. Q of 0. So you need to operate, you need to apply evaluation of function at the same time operation of function. So you need to replace x by 0. So we have here our q of x, so that's 0 minus 1 all over 4 plus n of x. So replace x by 0 also, 0 over 2. And then we have 0 minus 1, that's negative 1 all over 4. And then 0 over 2, that's 0. So we have negative 1 over 4 plus 0. Basically, when an expression or any number added to 0 will be the number itself. So we have negative 1 over 4. Therefore, our q of 0 plus n of 0 is equal to negative 4. Okay, I hope you got the correct answer for that. Okay, we have another one. Number 3, try to answer it on your own. Okay, pause first the video. And this is the solution. Okay, I hope you got the same solution with me. Now you try another one for number 4. It's multiplication. The quantity of q multiplied by p of 1/2. So apply first the evaluating of functions or evaluation of function and then proceed with the operation. Pause, pause the video for a while. Okay, let me show you. I hope you got the same solution and answer. But if you have the different solution, that's okay, as long as we have the same answer. Therefore, our q of 1/2 times n of 1/2 is equal to negative 1 over 32. Okay, I hope you got all the correct answer for number 3 and number 4. Okay, let's proceed now to composite of a function. What is the composite of a function? So as you can see, this is the figure looks like, or this is how we see it. It's f composition of g. So that's how you read it. F composition of g of x. So basically, how to get the composite of a function? Use the second function as the value of the variable x. And then evaluate function. Okay, that's how easy it is. So use the second function. So if our second function here, which means what's inside, that's g of x. So that will be the value of x of your outside function, which is f. Okay, how will you going to do that? Okay, let's try to see an example here. We have f of x, which is 3x minus 4, and g of x, which is equal to x squared plus 6x plus 5. Okay, number one, f composition of g of x. So this is how we do it. This is how we do it. Okay, copy first your what is outside, what is on the outside parenthesis, what function is on the outside. So it's f. So basically, we will be using f. So 3x minus 4, and then the value of x in your f of x will be replaced by the function of g of x, which is equal to x squared plus 6x plus 5. So you need to substitute this x squared plus 6x plus 5 to your x in f of x. So this is how we do it. 3 times the quantity of g of x, that's basically g of x here, x squared plus 6x plus 5 minus 4. And after that, apply here the distributive properties of 3 times x squared, that's 3x squared. 3 times 6x, that's 3 times x 18, and then copy x. 3 times 5, that's basically 15, and then write minus 4. You simplify and combine like terms. Basically, you can only combine 15 and 4. So 15 minus 4, 11. Therefore, our f composition of g of x is equal to 3x squared plus 18x plus 11. Number two, how about if it's a reverse? Let's see if they will arrive the same answer. Look at the answer here. It's 3x squared plus 18x plus 11. So situate it carefully if it's the same. Now, this is how we do it. This is how we do it. Okay. So we have f of x, which is in the inside. So basically, we will use g of x as the main uh, equation, and then substitute your x's there by the f of x function. Okay. So your x squared will turn into quantity 3x minus 4, since this is our f of x, quantity squared, plus 6 times the quantity of 3x minus 4 again, plus 5. And after that, simplify. Okay, first, this is a perfect square binomial. So all you need to do there is square the first term, which is 9x squared. And then for the middle term, that's first term multiplied by the last term times 2. So 3 times 4, that's 12, times 2, that's 24. And then copy the sign, negative. Okay. And after that, your square of the square of the last term. So 4 square or negative 4 square, and that's negative 4 square, which is 16. Okay. You can recheck that by separating both expression and then apply distributive property. Yeah, you can check that. After afterwards, 3 times 3x, 6 times 3x, that's 18x. And then 6 times negative 4, that's negative 24, and plus 5. After that, combine similar terms or combine like terms. So look at the equation. We only have one x squared here. So that's 9x squared bring down. As you can see, we have negative 24x and 18x. You combine them. Negative 24x plus 18x, that's basically negative 6xy, because it's a negative sign here for 24. So all you need to do is to subtract it. So 24 minus 18, that's 6. Copy the sign of the value with the greatest, the value of the great, or whose value is greater, so which is 24. The value of 24 is greater than 18, basically. Now, we have constant numbers, which is negative 24 and positive 5. So you combine them. Negative 24 plus 5, that is and 16. So we have 16 here. Constant 16 minus 24 plus 5. So you do it first like this. 16 and positive 16 minus 24, and then plus 5. That's 3. So basically, that's 24 minus 21. That's 3. Yeah, so copy the sign of the negative sign since 24 is bigger. The sign of negative 24 is 24 is bigger number than 16 and 5. Copy it. And that's your answer. So basically, their answer is different from the first composition, right? Therefore, our G composition of f of x is equal to 9x squared minus 6x minus 3. Now it's your turn. Solve the following. Let's have number 3. Okay, let's see if you are going to have the same answer with me. I'll pause the video. So, okay, let's see if we have the same answer. So our Q composition of P of 1/2 is equal to negative 13 over 8. Okay, so this is how you do it. So basically, you apply again the evaluating of functions and the operation of functions again. So for a moment, okay, so you are here, right? So I'm gonna show you first how I solve it here. So look at my board, guys. So this is my board. Oh, wait, this one. So we have, so you can do first, you can separate your solution, like find first the P of 1/2 and then apply it here below. So P of 1/2 is equal to, this is X, right? So X minus 6. So you substitute 1/2 to your X. So 1/2 minus 6. So basically, copy the denominator and then you operate that one. 2 divided by 2, that's 1 times 1, 1. 2 divided by 1, that is 2 times 6, that's 12. So 1 minus 12, it's negative 11 over 2. Actually, it's inverted because it's in the camera. Okay, I'm so sorry for that. So next, we have uh, 1 minus 12 is negative 11 over 12. Therefore, your value here for the x in the next, for the composition will be 1 over 12. So basically, we will arrive with the same answer, negative 13 over 8. How did you do that? This one, negative 13 over 2 all over 4. I do it like this. Negative 13 over 2 times 1 over 4. Negative 13 times 1, that's negative 13. 2 times 4, that's 8. So therefore, our answer is negative 13 over 8. Mhm. I showed you there a different solution. Now, let's try if you, so basically we're done with this. Let's have another one. Okay, you do number 4. Your P composition of Q of 0. Okay, pause the video first. I hope you have the same answer with me. So that is, therefore, our P composition of Q of 0 is equal to negative 25 over 4. Okay, thank you so much. I hope you get the correct answer. Okay, this will be the end of our video, guys. So I hope you learn from the examples I showed here in my video. But to learn further about operations of functions, you can search on your own. Thank you so much. Bye-bye.